Hello and welcome back. This video will start section 6.2, which is on more applications for the standard for normal distributions. In the previous section, we looked at standard normal distributions, and this is just a normal distribution that has a mean of 0 and the standard deviation is 1. And this is essentially the simplest normal distribution that we can see. Having a mean of 0 means that anything above the mean is going to be positive, anything below the mean is going to be negative, and it's pretty easy to sort of look at and understand. Now, in real life, not many distributions will have a mean of 0 and a standard deviation of 1. So for any old distribution, for any old normal distribution, we'll just have a mean, and we'll call it mu in general, and the standard deviation is just going to be sigma. And what you'll notice is that these will look very similar. If I could draw accurately, they would look exactly the same. These normal distributions, it doesn't matter what the mean is, and it doesn't matter what the standard deviation is, it is still the same bell curve. The mean is where the peak is, and we'll just denote that with mu. For the standard normal distribution, that's 0. And we can look at how far away from the mean we are using the standard deviation. Are we 1 standard deviation above the mean? Are we 2 standard deviations above the mean? Are we 1 standard deviation below the mean? Are we 2 standard deviations below the mean? And all of these will match up. So for instance, when we look at 1 standard deviation above the mean, and we look at this area is going to be equal to the area down here when we look at 1 standard deviation above the mean and the area above that. These are going to be equal as far as area is concerned. So rather than working with this normal distribution in general and using our complicated formula, the easiest thing to do will be to put it back into a standard normal distribution and analyze it here. So we'll just adjust the numbers so that they match up, and then we can use our STAT216, our calculators, to be able to calculate this. So let's look at an example. Here we've got IQs are normally distributed with a mean of 100 and a standard deviation of 15. Before we do anything else, I just want to draw a picture to sort of think about what exactly is going on here. So we know it's normally distributed, so it'll look like a bell curve, and with a mean of 100, so at the peak this is going to be 100, and a standard deviation of 15. So as we come out, I will label this every standard deviation away. So then they ask what percentage of people have an IQ above 115. So what we're doing is we're looking at this area here. We're looking at the area above 115, remembering that from the last video, probability, so what percent of people have an IQ above 115. If we randomly selected someone, what's the probability that they would have an IQ above 115? This is just the same thing as the area of this. Now, this is a normal distribution, a regular normal distribution. So what we'll do is we'll translate everything into the standard normal distribution. And so the mean for the standard normal distribution, so standard normal, the mean will be 0. And when we look at this, the value that we want is 1 standard deviation above the mean. So to get from 100 to 115, this is going 15 over, which is equal to 1 standard deviation. So when I go 1 standard deviation above the mean in a standard normal distribution, well, this standard deviation is just going to be 1. So I'm looking at this area right here. So if I open up StatCrunch and find my calculator, I can find this. So I go to Stats, Calculators, and I find my normal distribution calculator. I can open this up, and when I look at this, I want to find the area above 1, meaning I've gone from the mean of 0 to 1, so this is 1 standard deviation up, and this area off here is 0.1586. So when I look at this, this means that 15%, or a little bit more than 15% of values will be in this red section. So if I come back, I'll say that this is a little bit more than 15%. So so if I round, I think it was 7. So this is this area, but this area corresponds exactly over here. These distributions have the same shape, so it's going to be the same area. So what percent of people have an IQ above 115? So 0.1587, or about 15%. Okay, so turning scores, or turning values from a normal distribution into values from a standard normal distribution. There's a nice process for this, and this is called the Z-score. So the Z-score of a value is just how many standard deviations are you from the mean. In the previous example, when we looked at this, 115 is exactly 1 standard deviation above the mean. So 1 was our Z-score. How do you calculate this in general? Well, we see how far away x is from the mean, so we subtract the mean, and then we put it in terms of standard deviations. So this formula is what we'll use to find the Z-score of a data value. And what you'll notice is that this will have no units. The units on the top and the units on the bottom will cancel. So let's do an example with a bit more finicky numbers. So internal body temperature is normally distributed with a mean of 98.2 degrees Fahrenheit. If that was Celsius, we would be boiling alive. And a standard deviation of, I should include units here, 0.7 degrees Fahrenheit. So, so the question is, what percentage of people will have a temperature less than 100 degrees Fahrenheit? Or in other words, what is the probability that a randomly selected person will have a temperature less than 100 degrees Fahrenheit? So again, we'll draw a picture. I find that this is the most helpful thing for me. So our mean, our peak, is going to be 98.2. And we want to know the percentage of people that have a temperature less than 100 degrees Fahrenheit. So 100 will be somewhere over here. And I want to know how many people, what percentage of people is going to be less than 100. So if I come over here and draw my standard normal distribution, our standard normal distribution is 0. And we can see that, okay, we're going to be looking for a Z-score over here, but the question is, what Z-score? What value should I put in? Well, I have my formula. I'm going to see how far away x is from the mean, how far away this value is from the mean in terms of standard deviations. So my x value here is going to be 100. If I just ignore units for the moment, this is 100 degrees Fahrenheit. Our mean is 98.2, not 9.8, but 98.2. Our standard deviation, how spread apart our data is, our data are, is going to be 0.7. So our Z-score is going to be 100 minus 98.2 divided by 0.7. And this will be 1.2 8 divided by 0.7, which will be about 2.57. So I've rounded here, so I'll make that squiggly. So this value over here should be 2.57, and we are going to calculate this area. So again, we can come back to our StatCrunch, load up our normal calculator, and now we want the probability that value is going to be less than 2.57. So what you'll see is that this is a pretty big area. This is almost all of the curve. We've stopped when the curve is quite low, and we're looking at all this area. So it's 0.9949. So about 99.5% of people will have a temperature less than 100. So this area is going to be 0.99 if I round to 5, and that is also the same as this area. So what percentage of people will have a temperature less than 100? 99.5% of people. Another way to phrase this is, what is the probability that a randomly selected person will have a temperature less than 100? Well, the probability is 0.995. So I will do a few more examples of this in the next video.